record, and we will start. Okay, I have the where is the hold on. Okay, let me stop share. I cannot get to the okay. Yeah, the waiting room. I think I already initiated. Okay, then let's go back to our discussion. So you remember last class, toward the end of last class, we started the reinforcement learning. That's the third category. Is it? We also said that there are three categories, generally speaking, in machine learning: supervised, unsupervised, and reinforced. Okay, supervised, unsupervised. Previously, we already discussed quite a number of approaches, models. And reinforcement is also a big category, okay? And reinforcement, right now, there are not a lot of good libraries. Not like, like TensorFlow, is it, for CNN, for RNN, okay, for ANN, is it? It's neat, the high level carrots, and they make they make a lot of job easier. But for reinforce right now, there are not very general approaches to deal with general questions. Mostly, it's just I know some of the game, like OpenAI Gym, the game, okay, they have some limited supporting because so there are a lot of potential if you are interested and you want to do some development regarding this, okay. But anyway, this is also a big topic, okay, reinforcement learning. And last class, we kind of started with the concept. Reinforcement learning right now, especially used quite a lot for all sorts of game. Okay, so if you interested in game development field, is it that maybe one of the field you can go to, okay, reinforcement learning, do some more digging, okay. And for reinforcement learning, so here is a very general about Q-learning. So one of the, so this is not a deep learning, okay, it's just a regular Q-learning involved with the Q table, okay. So over here to give us some general ideas. So in reinforcement learning, it's the agent. That we have some agent, etc. So agent need to make some decision based on some policy. So the Q table's purpose is to keep training to find optimal. Here we didn't see best, okay, we just see optimal policy, okay, so that agent based on that policy can take some action. Is it take some action on the environment? Is it? And so the agent will be at some current state. So over here it says state ST, is it? And so over here it involves state changing. So the Q table, the rows is regard all of the states. Is it a state 0, state 1, state 2? So just like you see when you play chess, is it before you move one step, that's a state. You move a step, that's the next state. And you move, that's the next state. Is it? So it can keep track of all of the states. Is it? So you have the current state, you have the next state. Is it? So that's over here, it shows the next state. And based on the action taken based on the policy, is a policy, and you will get the reward or penalty. It can also be penalty, is it? So based for the current state, apply some policy, you can get some reward or penalty. Is it? Same thing for the next state, you can also kind of predict, is it next state I take some action, can I get some reward? Is it something like that? Okay, and then both the current state, so the key point for Q learning is, we said it's not just based on the immediate immediate rewards. So not just count on immediate rewards. You also consider future. You also consider future. Later on we will see that table, that the futures. So that's why you see for this Q table, so the Q table is keep updating. Keep updating, okay. So each of the entry in this Q table is a Q value. Okay, the Q value. And the columns of the Q table is actions. And actions based on policy, So you can have multiple actions, just like the chess, You move up or you move down or you move diagonal, You move left or you move right, How you move, So that's called actions, okay. So based on the state and the actions, You will receive reward or penalty, okay. And we are going to find some formula to calculate the Q value, okay. And then you try to get the maximum reward, okay, maximum reward. That's our target, okay. So that's the general idea about Q learning, okay. So right now it may still look kind of what that really is, So let's see more. So over here, we are going to use an example to discuss about Q learning. So here it says a intelligent taxi, okay. So in some certain field, okay, it's going to pick up the passenger at one location and drop the passenger off at another location. Okay, at another location. So we need to drop off to the right location. That's one of the tasks you need to do, And you want to save time, to take minimum time, to take time. And of course, you need to follow traffic rules, So here, it says for reinforcement learning, okay, we need to consider rewards, states, and actions, We are going to see these three components. So what are the three in this specific application? Okay, so what will be the reward or penalties? Because we are going to try to calculate the Q value. That is a Q value. So we need to know what you get for reward or penalty. So here it says the agent going to receive high positive reward if you have a successful drop-off, okay? And it should be penalized if it tries to drop off in the wrong location, okay? We cannot just stop with reward or penalty, Because over here, there is another important thing is you will not be able, so in reinforcement learning, it's not just one step you will reach from the source to the destination, as it involves multiple steps, multiple steps. So each step, you will also get some negative reward because it's not the destination yet. Okay, so every time step, we also have some slightly negative reward. Okay, so that's the idea. And this idea, like last class I explained, but it's not same thing, but have some similarity. Okay, and if some of you guys right now in data communication, you learn routing. Routing, and you learn digester, shortest path first, and you learn also Bellman-Ford, So this is kind of, but it's not the same thing, okay? But Bellman-Ford at a certain level, okay, has some similarity, like the reinforcement learning. Okay, that's just my personal opinion. Okay, because I I know the bare method, those routing like a digester routing, etc. And then when I investigate reinforcement, the Q-learning, I see, oh, yeah, there are some similarities, etc. But not the same, because over there, you don't have like this kind of time step. There is no time step, that kind of issue, okay? But over there, it's not reward. It is you try to find the least cost, is it? But it's a similar concept, is it? Least cost routing, is it? So there are some similarities, okay. Okay, so that's regarding reward. And the next, you remember we said there are three components. Is a reward. We need to think about state and what? And action. Is it? And the Q table is state and action. Is it? And then you have the Q value. Is it Q value? Is it in each cell? Okay. So what is this smart cap state space? Is it state space? Okay. So here, the simplest scenario here is that we assuming this is a parking lot. Okay. And we divide this parking lot. So this may be a game you design. Is it? And you split it into 5 by 5. Is it cells? Okay. And we have this 4 specific location, okay, we call RGYB, okay. Those locations, it's you can pick up and drop off a passenger. So those are the location you pick up and drop off passengers. And because it's a grade, so you can specify them just like the index, 2D array index, look, as a row and a column, etc. Okay, so we have that, and here in this diagram it shows, so this is a taxi, etc. And so the 5 by 5 grade is has already give us 25 possible taxi location. So taxi can be any of this 25 cells. So we have that 25 taxi location. But totally how many about the state space? Is it state space? So the destination. So how many destination? So you have RGYB. Is it? So we have 4 destination. Is a destination. And how many location passenger will be? And of course, this 4. Okay, but there is another thing we needed to think about is the passenger also inside the taxi. Is it? So there will be 5 cases in this case. Is it? Then total possible states is what? You have 25 for taxi. Is it? So that's 5 by 5. Is it? And the passenger can be any one of the 5 location. Is it? So then that's 25 times 5. And then you have 4 destination. So that's times another 4. That's why total we come up with this 500 states. So this table, Q tables, number of rows is 500. Okay, so that's this Q table, the state space. And the next, let's see, what is the action space? Okay, so what kind of action the taxi can take? The taxi, when it's driving, is it? It can take south, north, east, and west on the grid. Is it? It can also do pick up and drop off. Is it? So there are 6 actions. So the Q table, then it's going to be a 500 by 6. Is it? Okay, so, but of course, it said on the diagram, is it on the grid, the taxi cannot perform certain action in certain state. Is it because of obstacle? Is it? some place you have a war, so the taxi cannot directly go to there. Is it so? So that's not allowed. Is it? Then is that in the environment, you just provide a negative penalty for every war hit. Is it? Because taxi cannot move anywhere. Is it in that case? Okay, and that's the general about the actions. Okay, so over here, we are going to use for reinforcement learning, use a lot of from the OpenAI Gym. OpenAI, so it provides different game environments. Okay, so if you're interested, you can investigate more. Okay, so what we are going to use the gym environment. So the environment is already designed for you. Okay, so you don't need to worry about the game environment, everything. We just focus on the reinforcement learning, the part. Okay, so this gym environment, one of the game we are going to use is taxi, but basically you will see in my code it's already version 3. Okay, so now the latest is version 3. Okay, version 3, and the objective is that rewards and actions are all the same. Okay, and for the gym, if you want to use you need to also install the gym. Okay, and that's the general environment. So next, let's take a look. Let's go to the coding part. Okay, let's see where I need to get to that point. Okay, it's this one. And for this one, I use Colab. Okay, if you use Google Colab, you don't need to worry about the environment installation, everything. Okay, so it's save a lot of work. So I just use the Colab. Okay, so of course you need to import something. Okay, here one thing you need to import is from Python display and clear output. Okay, and this is that gym. Okay, so OpenAI Gym. Okay, in reinforcement learning. And I have these notes also on our course website. Okay, so you can read more in detail. Okay, and to set up the environment, you need to gym make, so mention the name. Okay, so here is version 3 text and get its environment. This is the environment, because in reinforcement, environment is also one component. And then if you call render, did you see it give you this this game environment drawing? Is it? So it simulates the 5 row and the 5 row and the 5 column cells, as if that parking lot, and it's also identify the location. Is it RGYB? Is it? And the whole over here, you can also get the total number of states and action. Is it? It's called observation space and action space. Is it to give you the total number of states and the space? And here in this diagram, the color blue is that it's passenger. So right now, so the default one passenger is here. Okay, at the left bottom corner. Is it? Magenta is that it's the destination. So this is going to be the destination. Is it? And the yellow means it's empty. So right now taxi is at 0, 1, 2. Is it? It's 2, 1. Is it? Third row, the second column. Okay, so it's an empty taxi. And if the taxi get the passenger, it will show a full taxi. Okay, so that's going to be a green color. Okay, later on you will see when we run the game. Okay, and here first it's just to show some random steps in the game. Okay, so that we can see how the game looks like. So you just get to the reset. Okay, here we also collect total rewards. Total rewards. Okay, and then we render as it. That's the default one. So we will just run 6 random one. Okay, 6 random step. So you can take the action. Here, if you call the sample, that will give you a random action. And we have 6 actions. Is it? So go to top, south, west, east, etc., and drop off and pick up. That's the 6 actions, etc. So this will give you, so each action will be 0, 1, it's to 5. It will get a number, okay? So you will get a random number here between 0 and 5, is it? Then you take that action, that the agent will take that action. Will take that action, what it will give you? The gym environment, it will return you the observation, the reward, if it's at the destination yet, and some other information. And you can add, accumulate your reward, is it? And you can also plot the current state, okay, clearly see what it looks like, is it? And then we can also get the reward, is it? Okay, that's this part. Then let's take a look at the running result. If you take a look, the running result, did you see this is the initial, the default one? Okay, that's this case. So the taxi is here, is it? And the passenger is here, is it? Okay, then a random action set. So we run this sample, is it? This random action is what? Is moving to east. Is it moving to east? Is it? So that's east. East, but it's not to the destination yet. So we slightly penalize. So the penalty is -1. Is it? Oh. And let's see. And then because it has 6 random ones, it's the next one is, oh, the random one go to north, is it? And the reward, is it? So this is just all random. Is it all random? Is it 6 random? So each one you can get the reward. Is it? You get the reward. And if you take a look, the last one says the taxi drop off. That's the action. Is it? Drop off action. But that's the wrong destination. Is it? The destination is supposed to be here. Is it? So it's wrong. So that's why you get 10, -10 reward penalty. Is it? And if you drop at the right location, you will get 20 reward. Okay, in this game. Okay, this just shows us some random action. Is it? Okay, so next, in this game, you can also, because you may want to say, oh, I want to set my car to some place. Is it? You can do that. Is it? And then let it take some action. It's, oh, no, this is a passenger index, okay, and the destination index. So you can also set some environment, is it? Set some state, is it? So this is a specific state, is it? So the taxi's location, is it? Passenger location and the destination location, is it? That's how our 500 comes from, is it? Comes from taxi location, is it? Times what? Passenger location. The possibility, is it? Not the possibility, the states. So the taxi's state, is it? The passenger's state, is it? And the times the destination location, is it? The state. Is it? That's how we come up with total 500, is it? Okay, so this one you said, okay, I want to set a specific one, is it? And in this gym, you can render it. You can also get to the state. So the state index is 328. Because total you have 500, so each one has the index. So this is the index 328. Okay, that's regarding, so this specific state regarding in that state index, it's 328, and it shows off, is it? It's the drop off where the passenger, where the location, okay? And also over here says you, from the environment for that specific state, you can also collect some information. Okay, some information. So what over here is 6 action. So at this specific state, you have these 6 available actions to take, is it? And here it shows possibility, it's all equal. So this is the next state you can move to, is it? And here is the rewards. So you will get to -1 or -10, is it? Here is if you are at the destination or not. Okay, so if the game is done, we call it if the game is done or not. Okay, so you can also collect this kind of information, okay, from the environment. So what next one we are going to see is we are going to let of a game, is it, start at this specific state. Okay, then we will see, we will just let it run until it find the correct location. Okay, so this is called brute, this is just called, so we don't have any intelligence. Okay, so you just keep random trying. Random trying. Okay, and then let's see how long it's going to take the taxi ride. So the taxi kind of just random, and then just random driving, and then to see how it can get to the destination. Is it starting at this state? Is it? That's what it does. Okay, so here we have a certain number of epochs we need to collect. We also want to collect penalty and reward. And each frame we're also going to record so that you will be able to run the video, basically. Basically, for this game, you can record the video, okay, the whole simulation. Okay, so over here, you take some random action, is it? And then you let your agent move that step to that random action you take, is it? And it says, okay, if the reward is -10, is it? That means it's a wrong drop off. Then you add penalty because you want to see totally how many times penalty this random run got, is it? And you can also append the corresponding information for the specific frame because we are going to do the animation, is it? Okay, so you get the state, action, the reward, is it? And the environment render, is it? And what is the mode? Okay, so this is straightforward, is it? And after we run, I'm not going to run because it takes too long, but at home you can try, okay? And this is total time it takes. And did you see, it takes quite a number of wrong penalties until this taxi finally get to the correct location, is it? So it's not very efficient, is it, with this random way, is it? And here is how do you print, is it? So basically you can animate. If you run, you will see it's keep changing, not this last, this is the last step. Okay, last state. Okay, last state already drop off at the right location, is it? Yeah, so that's why you see here, it get the reward 20, is it? Okay, so that's not good, is it, with random? So in reinforcement learning, so Q learning, also be careful, it's not too greedy. Okay, greedy means explorer, exploitation. Is it? Exploitation is each time you just pick the largest reward. But if you always do this, that can lead to overfitting. Is it? So in Q-learning, in order to balance the overfitting, we introduce a concept we call it exploration. Exploration is just some random action. Random action. Okay, so that's the idea. So anyway, so over here, we have, oh, so before we move on to this, let's go back to the concept part. Okay, let me find that the Q table. Okay, the Q value. Okay, how do we update the Q value? This one. Okay, so you remember our goal is to find the maximum, so get a maximum reward, but it's long run, okay, long term to get the maximum reward. Is it? So in that Q table, it's the Q value, okay. So initial, you will initialize that key label with just some random value, all zero. In our case, it's all zero, okay. And because the agent state and action keep updating, is it? You want this table finally provide you the optimized Q value, okay? So that you will know, okay, at this state, take this action, then I will achieve my goal, is it? So the Q value updating, so it's based on state and action. That's the current state, is it? What is that? So here to use alpha. Alpha is some learning rate. Okay, you remember previously when we discuss like neural network, we also have a learning rate. Is it the concept? And there's another term called gamma. Okay, gamma is discount factor. Okay, discount. So this is to try to introduce exploration. Exploration, okay, so discount to avoid exploitation. You don't want to too much exploit. Exploit is take advantage. Is it? Okay, so here is, okay, the current Q value, is it? Q value, then you use 1 minus that learning rate, you get the current Q value. Plus what? Plus, that is the learning rate, okay, times the reward, plus that discount. And this maxima is about, so this Q value is regarding next state and all action. So basically it's some one row. Is it? So here is all actions, all actions. So certain row, that's a certain state, is it? But this is the next state. So among all of these values, you're going to find the maximum one, is it? This is what you try to do, exploit, is it? You want to get the maximum reward, is it? But you see here, I said I want to add some discount. I'm not always going to use it, is it? As some discount. So try to lower it down. So that's why we said we find a balance between exploit and explore, okay? Okay, so that's the idea about that Q value, okay? How do we update? So let's go back to our code. Okay, then regarding this Q table, how do we use that? Is it? So Q table, you see we have alpha, we have gamma. So this epsilon is for the discount. No, the gamma is for the discount. Okay, so this is epsilon is, I shouldn't say for discount, is for the choice between exploit and explore. Okay, so that's the cutoff value for you to make the choice. Okay, initial the Q table, we initial all 0. Okay, so it's 500 by 6. Is it? So you can see that. And the number of episodes you set, certain number of episodes, and then you let it run. Okay, number of episodes. So you will, with each episode, you let the environment start at its default state. Okay, and then here we keep track of reward, and if the car get to its location, is it terminated or not? Okay, then next, let's see. So then in this big loop, is it, here it says, okay, if the random value is less than epsilon, is it, then I'm going to take random. So I'm going to do explore, this action. So action we are not from, so not from Q table, just some random one, is it? Otherwise, you are going to take the maximum value from the Q table. Is it? From the Q table, okay? So once you have the action, is it? You can move it, just like the chess, you move it one step, is it? Then you can get next state, the reward terminated on some other information, is it? And based on that, you have the current Q table, Q value, is it? And you can find the corresponding next, the maximum one, is it? Okay, and then you can update. So here you update Q value, is it, in your Q table. So be careful, okay? So Q table is updating. Okay, until you finish running of this game, is it? In this case, is that 10,000 epochs, is it, the simulation? Then your table, then you have your train table. Okay, so the purpose here, for some reason that's not working. So the purpose here for the reinforcement learning, is it to get a train Q table? Okay, Q table. You remember for supervised learning, is it, of a game, of a goal, is it, for neural network, is to train weights, is it, to train the weights, is it? And here is we try to get that Q table, okay? So here you keep updating the Q table, is it, with this new Q value, is it? And then you set your state to the next. So it will keep doing, is it? Keep simulate your game, just like you play the game, is it? And we are not going to draw every episode. So if a certain episode, then you can let it give you that environment drawing, is it? Okay, so that is what this part is doing. Okay, so here it shows the result, is a running result, and then we get, so after, so the training is complete, is it? After training is complete, you have your Q table. Is it Q table? So here we have 1, 2, 3, 4, 5, 6. Is it? So this is action 6, action 5. Is it? Action 1. Is it? So here is state 1. Here to state 500. Is it? So you have the Q value. The Q value. Is it? Each one you have the Q value. Is it? So for each state, you have 6 actions, their corresponding Q value. So this table, you have this table. Once you have this trained Q table, of course, next you can evaluate, is it? And you can predict, is it? If you have certain things, is it? certain state. So like over here it shows, okay, you have the state, is it, and we render, is it, and then you just let the car to drive, is it, based on this Q table, is it? How does it do? It will from the Q table always find the best reward and then take the action. Is it take the action? Then it will tell you what the next state is it? So this state will be from like state to next state and then to next state. Is it to next state? So you just follow the trained Q table and always find the maximum reward state. Is it state? And so that you won't have a lot of penalty. Is it? And then in this case, finally you will get the result. Is it? You will get to the destination. You will drop off the passenger successfully. Is it? So over here you see, we from that trained Q table, is it here? Here we have this state, is it? So each state, do you see it then get to the pickup, is it? Pick up the passenger, did you see? And it's the full car, is it? Full car. And lastly, did you see it? The car arrive at the right destination, is it? So once you have the Q table, okay, the Q table, then the trained Q table, then you can just follow that and get to the destination. Is it? So that's why I said this concept, because in routing, is it, in network, for that Bellman fault, is it, you also have this kind of table, is it? We call it routing table, is it? That routing table, you just follow the routing table, then you will also get the least cost route. Is that least cost route? So you can see a lot of similarities between this, but of course the updating process is different. Okay, and then here it also shows with what we just trained our Q table, is it? So this is regarding action. So this is for state 328. Is it 328? So in that parking lot, is it? So maybe the passenger is here, is it? And the car is here, is it? You have passenger, you have car, and then maybe the passenger want to go here. This is a destination, is it? So the car needed to find the passenger, is it? Pick the passenger up and then follow the Q table to get the destination, is it? So how do you do that? So based on this state, is it, here is your Q table. You have action 0, action 1, action 2. This is action 5. Action 5, is it? Among this, let's see what's the largest Q value. You want to find the maximum Q value. Is it, which one it is? Okay, it is this one. Is it? Oh no, not that one. Is this one? Is it? This is so suppose this is north and this is south. Then it tells, okay, the taxi needed to go to south. Okay, so and when the taxi at this stage, then you go back to check the Q table. It says, oh, you may need to go to left. Is it? So you just follow it, then you can get to the destination. Okay, so that's the Q table. And what the next part just shows. Oh, okay, next one is just show some 100 episodes, okay, and with our trained Q table, is it? So this is kind of like our testing and prediction, okay. Okay, so, Okay, so that's